Assalamu alaikum everyone. I am Sabah Kiran. Today I am here to deliver a lecture on the topic of ortho and para coupling in NMR. In this lecture I will tell you about the coupling in NMR and what are the ortho, para and meta coupling. So I will start from the introduction of coupling in NMR. So the coupling in NMR is the interaction between nuclear spin in a molecule. We can say that NMR coupling is also known as spin-spin coupling that occurs through the electron in the bond between atoms. Due to this interaction that leads to splitting of NMR signal into multiplets. This coupling gives us structural information about the molecule. In the next slide, I am going to discuss the types of coupling in an aromatic ring. In aromatic compounds like benzene and its derivative, we mostly see three types of coupling. The first one is ortho coupling, then meta coupling and para coupling. So the coupling constant depends on the distance between the proton. Here I take an example of chlorobenzene. This is the structure of chlorobenzene, which has 5 aromatic protons and the chlorine atom is attached at position 1. So we label the position like this. 2 and 6 indicates ortho position, 3 and 5 indicate meta position, and the 4 indicate para position. I will discuss ortho, para and meta coupling one by one. The first one is ortho coupling. Ortho coupling occurs between adjacent protons, for example, at carbon 2 and carbon 3. So its J value is about 6 to 9 Hz. Ortho coupling gives clear and strong splitting in NMR spectrum. It is commonly observed in aromatic compounds. Then meta and para coupling. Meta coupling happens when protons are one carbon apart, like from carbon 2 to carbon 4. Its J value is about 1 to 3 Hz. It is weaker than ortho coupling but still visible. Then para coupling. It occurs when the proton are on opposite side of the ring, like from carbon 2 to carbon 5. Its J value is very small, which is around 0 to 1 Hz. It is too weak to be seen in the spectrum. So I will explain it more with the help of spectrum. So here it is the spectra of chlorobenzene. Here the structure of chlorobenzene, you see the protons at ortho, para and meta position are denoted by different colors. So the proton at ortho position give doublet peak and the proton at meta and para give triplet. It is same for the left side of the ring. The ortho position are close to chlorine. We say that it is highly deshielded, and the meta proton are slightly less deshielded, and the para protons are symmetric that appears in between. Why the ortho proton are highly deshielded, also the meta protons are highly deshielded, and why para appear in between this in the spectra. So this is because of the aromatic ring and the presence of electronegativity of chlorine. So the chemical shift appeared downfield, which is 7.0 to 7.5 ppm. So that the splitting pattern is a multiplet due to the coupling between non-equivalent proton on the rings. Then Here I am going to discuss NMR splitting pattern in chlorobenzene. So in chlorobenzene, each proton appears as a multiplet due to coupling. For example, when we talk about the proton at ortho position, that show clear splitting because they are close to each other. Furthermore, the meta proton cause smaller and fine splitting, and the para protons cannot show visible splitting. So use J value to analyze this pattern. At the last slide of my lecture, here I mentioned that which coupling is the strongest one and which give more clear spectrum in NMR. So the first one is ortho coupling, which is the strongest one with a J value of 6 to 9 Hz. Then meta coupling, that is moderate with a J value of 1 to 3 Hz, and the last one is para coupling, which is the weakest with a J value around 0 to 1 Hz. So understanding this coupling that helps to analyze aromatic compound in NMR more easily. So here I have prepared some multiple choice question from my lecture. So you guys go go and check these multiple questions and also check your understanding level. So that's all about my presentation. Thank you very much.